I talked about how modeling choices affect the cost of greenhouse gas emission reduction, but policy affects those costs too. I've shown this study before in a tabular format. Now we have it graphically. On this axis, we have the stringency of climate policy measured as emissions in year 2050 relative to the year 2000. And as you move to the right, emissions go down. That means that policy becomes more stringent. The interesting bit on this graph is that for very stringent climate policy, there's a whole bunch of models that say, I can't solve this or I won't solve this. And there's three reasons why there are so many dots and triangles in this block. Now, the first is that some modelers refused to report these results. And one reason for that is that the carbon taxes became so high in the model that the modeler said this is unrealistic. In other cases, that's a few of cases only, the physical part of the model simply could not reach the target. Essentially, the argument was that we've reached this is a 2 degrees target. We've reached the 2 degrees target already. But in most cases, most of the models that don't get here, it is because they did not have the technical options in the model to cut emissions so deep. Now, this is an older study. Here is a similar study, but newer, and you actually see the solution. As we move from top to bottom, climate policy becomes more stringent. You see that here as well. Emission cuts are steeper. This is now emissions in the years 2030, 2050, 2100 relative to the year 2010. And emissions in 2050 here can be roughly equal to the emissions in 2010, but here you see an emissions cut of around 70% for CO2. The trick that they actually can reach these fairly stringent targets. This is still around the 2 degrees target of the Paris Agreement, not the 1.5 degrees target of the Paris Agreement. What you see is that in the year 2100, CO2 emissions are more than 100% below emissions in 2010. That is, we are sucking CO2 out of the atmosphere. It's not just that we stopped adding CO2 to the atmosphere. No, in order to reach these targets, we need to start sucking CO2 out of the atmosphere. And in this particular study, that was seen as an unrealistic technology. In this study, this was seen as a realistic option. The costs of this are shown in this graph. We have carbon prices, we have consumption losses, we have changes in GDP. And what you see here is that if you move further to the right in any of these specific graphs, you move further out in time, but within each time period, if you move further to the right, you look at more stringent climate policies. So these are the very stringent climate policies, and these are much more lenient climate policies. And what you see is exactly what you would expect, that a more stringent target leads to higher costs. Now, I talked about the costs being negligible over this century. That is true for lenient targets, where we're talking about GDP losses by the end of the century of 2, 3, 4, maybe 5% of GDP. And in the year 2100, in an economy that is growing 2% per year, so losing 2% of that at the end of the century essentially means you've lost 2 years of growth out of 80, so that is a relatively small loss. But for more stringent targets, you see that the costs actually start to escalate. No surprise there, the more stringent climate policy, the higher the costs. This graph is also interesting. At the moment, the This is the carbon price. At the moment, the price of carbon in Europe and California, the two most stringent, the two most green jurisdictions, the price of carbon is around here. And what you see is that for the more stringent climate targets, for the ones that are codified in the Paris Agreement, you actually need to go up a bit. And this is a logarithmic scale, so you need to go up a fair bit. And then by the year 2100, you actually need to go up quite a lot. So if the price is currently around $20–30 per ton of carbon, dollars per ton of CO2, sorry, it needs to go up to 2–300, maybe, oh sorry, 2–3,000, and maybe more than that. So that is quite a bit of price inflation. It is also important to note that the relatively high prices, the 2030, only apply to the EU and to California at the moment. And the price that is shown here is the global price. So this actually, in order to meet the Paris targets, there's two things that need to be done. First, the world needs to be convinced that it should adopt climate policies that are as stringent as currently in the EU and California. That is one thing. And actually, we need to intensify those policies already now and keep on doing that for the next 80 years or so. So this is a pretty tall order to meet the upper bound of the Paris Agreement. So the choice of target greatly determines the price of climate policy. That is the first thing I want to say. The design also matters. So we go back to the older study now, and what you see is that as the climate policy becomes more stringent, this is not quite Paris, but slightly above, this is nowhere near Paris, you see that the costs escalate. But that is true in the blue. Now, the blue scenario assumes that the target holds for the end of the century. Essentially, it says it doesn't matter what happens in the interim. If in the year 2100 you have hit your target, you're fine. But if in the year 2090 or the year 2080 you actually exceed the target, that is no problem. That is, you approach the target from any direction, from above or below. In red, you need to meet the target not just at the end of the century, but throughout the century. So you approach the target from below. What you can see is that for a stringent target, the 450, you double the carbon tax that you need to impose. So this seemingly innocent constraint that you need to approach the target from, it's not just about hitting the target, but about approaching the target from below, doubles the costs at the margin for stringent climate policy. So that is one thing that matters here. The second question is who is part of this climate policy? And in the blue and the red, everybody imposes a carbon tax right from the beginning. In the green scenarios, rich countries go first, then middle-income countries, India, China, follow by 2030, and currently poor countries, Africa, follows by 2050. And if that happens, then the costs at the margin triple relative to full participation. The reason for that is simple. You have a fixed target. In the blue and the red scenarios, everybody works towards that target, and therefore the costs are relatively low, the effort is relatively minor. But in the green scenario, everybody, or only few, work towards the target. The target is still the same, and that means that those few need to work much harder, and therefore the costs are much larger. So policy design matters in how do you actually define the target? End of the century or throughout the century? But just as important, who is actually working towards this? And as soon as you start exempting countries, or as soon as you start exempting sectors, not shown on this graph, but the principle is the same. As soon as you say, well, electricity has to solve the problem, but we leave transport alone for now, that means that you increase the cost, and you increase the cost quite considerably. So stringency matters, and participation matters for the costs of climate policy. Timing also matters, and this is an older study still. What you're looking at here are two alternative groups of scenarios. This is a scenario without any climate policy. Then this is a scenario that is fairly stringent. In the long run, they are the same. Let's focus on 550 for the moment. You can sort of get there through two pathways, the dotted black one or the solid light blue one. This is for the concentrations. The difference is perhaps better seen if you look at emissions. If we go to, let's pick this one, you can sort of follow the no climate policy path, then turn late and then come down quickly. Or alternatively, you can start deviating immediately, and then, of course, because you work harder in the beginning, you need to work less hard in the end, and emissions come down more gently. So those are two alternative paths that you could take. Essentially, the choice is between doing a lot now and therefore doing less later, versus doing less now and therefore having to work harder later. And the question is, which of the two is cheaper? Well, here is an assessment with 6 different models, and in order to look at the cost savings from delaying action or postponing actions, you need to compare the first and the third, or the second and the fourth. And what you see is that postponing action, depending on the model you're looking at, is quite a bit cheaper. So according to this particular model, you may save $3 trillion, still quite a bit of money, but according to this model, you may actually $3 trillion, and that may be 10% of the cost. And here you're looking at a larger absolute cost saving of around $6 trillion, and actually the costs fall by 2/3, so a relatively large cost saving. And that is true for all the 6 models that you're looking at, and also the variance of the scenario. So working harder later, postponing action, is economically profitable. There are 4 basic reasons why this is so, and why similar results have been found later in other studies. The first is the capital stock turnover. We talked about that before. A lot of emissions are set in stone, and that means that if you start with a very high carbon tax now, you're essentially just imposing costs on people without having them change their behavior. And that is because our emissions are driven by the buildings that we work in, by the houses that we live in, by where we work versus to where we live, and how we get there. And those things don't change overnight. Even if a very high carbon tax is imposed, we're not all going to pick up sticks and move closer to work or to school. We're all not going to sell our car immediately and buy a newer one, and so on and so forth. A lot of emissions are simply set in stone. So what matters is that when we replace things, we replace it with more fuel efficient or lower carbon options. But if you just impose very high carbon tax at the beginning, you just impose a dead weight loss on the economy without a change in emissions. And so that is one reason. Second reason is that the because of changes in relative prices, because technological progress in renewables is much faster than technological progress in fossil fuels, we expect future climate policy to be cheaper than current climate policy. We expect emission reduction to be less of a problem in the future than it is now. And that means that doing the heavy lifting later, doing the steep emission reduction cuts later, is better than doing it earlier. Third reason is the discount rate. Incurring costs later is steeper than incurring costs earlier. And the fourth reason, very similar to that, is the carbon cycle. If our target is emissions or concentrations in the year 2350 or 2300 or even in the year 2100, then cutting emissions in the year 2020 is less effective than cutting emissions in the year 2080. And that is because if we put CO2 in the atmosphere, most of it is degraded slowly over time. That is just how the carbon cycle works. But it also means that the effect of emission reduction is slowly degraded over time. And if our target is the year 2100, then emission cuts in the year 2090 are simply more effective in meeting the target than emission cuts in the year 2020. And for those four reasons, very basic reasons, it is cheaper to start slowly deviating from the no climate policy path in the beginning and accelerate your ambition over time than it is to start with a big bang and go slow later.